Okay, so in this video, I'll be going over on how to solve exponential equations, and we're just going to look at basic equations that don't involve logs. So let's go ahead and get started with our first example. And our first example is going to be 4 to the power of 2x plus 3 is equal to 1. So from here, we could just go ahead and see that if we use a rule, whenever we have the exponent is 0, it is always going to equal 1. So with this, we can go ahead and just say that x, well, here, since we have 2x plus 3, and if we have 4 to the power of 2 times 0 plus 3, that is going to give us 3, which we don't want. Instead, we would go ahead and solve the top part. 2x plus 3 is equal to 0. And then just subtract 3 from both sides, and that will give us negative 3. And divide both sides by 2, where we get negative 3 over 2. So that is going to make our equation equal to 1. Since we have 4 to the power of 2 times negative 3 over 2 plus 3. The top is going to give us negative 3 plus 3, which is going to give us 4 to the power of 0, which will be the same thing as 1. So here we have x is equal to negative 3 over 2. So that's a relatively pretty straightforward answer. And we're going to go ahead and look at another example. So we're going to have 3 to the power of 1 minus 2x is equal to 243. So we can go ahead and find what are some factors of 243. And if we go ahead and try to factor out 243, we can go ahead and find that 3 is a factor. So we have 3 times 81 is the same thing as 243. So we basically get that. And we could also factor 81, since 81 is the same thing as 3 to the power of 4, which is gives us 3 to the power of 5, since 3 times 3 to the power of 4 is the same thing as 3 to the power of 4 plus 1, which gives us 3 to the power of 5. So we can rewrite our entire equation to give us 3 to the power of 1 minus 2x is equal to 3 to the power of 5. And since we have the same base, we can just cross them out for now and find x alone, which will give us 1 minus 2x is equal to 5. And if we go ahead and solve for x, we just subtract 1. We have negative 2x is equal to 4. If we divide by negative 2, we have x is equal to negative 2. So we just go ahead and verify that. So I have 3 to the power of 1 minus 2 times negative 2, which will give us positive 4. So 3 to the power of 1 plus 4, which is the same thing as 3 to the power of 5, which will give us 243. So that is our second example. And now we'll go through a much more difficult one. So we're going to have 6 to the power of 3m times 6 to the power of negative m, which is equal to 1 over 36 to the power of m. So here we can just go ahead and group the left-hand side first, which will go ahead and give us 6 to the power of 2m, because since we have 3m minus m. That's going to give us 6 to the power of positive 2m. And all that is equal to 36 to the power of negative m, because on the right side we have 1 divided by 36 to the power of m. And if we use this rule, we can go ahead and have that written out as 36 to the power of m. So now we can go ahead and find that 36 is a perfect square. And if we take the square root of 36, we get that it is equal to 6. So we then end up getting 6 to the power of 2m is equal to 6 to the power of negative 2m. And here we can go ahead and solve for m. So we have 2m is equal to 2m. And we have two different solutions. Since if we subtract 2m from both sides, we're simply going to get that it is equal to 0 is equal to 0, which is not going to give us a solution. But if we plug in m is equal to 1, we get that 2 is equal to 2. So we have either no solution or one solution, that is m equal to 1. So when we come up with equations like this, we basically just go with the assumption that there is no possible solution that satisfies our equation. So with this, we go ahead and try m is equal to 1. And if that is wrong, then you can go ahead and just say that there are no solutions. So we have 6 to the power of 3 times 6 to the power of negative 1 is equal to 1 over 36. And here we have 6 to the power of 2 is equal to 1 divided by 36. And we see that 36 does not equal 1 over 36. So we can basically go ahead and cross that out and say that there is no solution. Since we had 2m is equal to 2m, we just get 0 is equal to 0, so there is no solution. Now we're going to go ahead and look at 3 to the power of negative 2x plus 1 times 3 to the power of negative 2x minus 3 is equal to 3 to the power of negative x. So we're going to go ahead and group the left-hand side. Since they all have the same base, we're going to get 3 to the power of negative 2x plus 1 plus negative 2x minus 3, which is going to give us 3 to the power of negative 4x minus 2. So we have 3 to the power of negative 4x minus 2 is equal to 3 to the power of negative x. So here we have negative 4x minus 2 is equal to negative x. And we're going to add 2 to both sides and x as well, so that we get negative 3x is equal to 2. And here we just get x is equal to negative 2 over 3. So here we're going to go ahead and verify that. And we're going to get, let's write out in green. So we have 3 to the power of negative 4 times negative 2 over 3 minus 2 is equal to negative, or 3 to the power of negative 2 over 3. And that is going to give us negative 4 times 2. That's going to give us positive 8 over 3 minus 2. And here we have that this is going to be the same thing as 2 over 3, since we have 8 minus 6 over 3, which is going to give us the same thing as positive 2 over 3. So here we're going to get 3 to the power of 2 over 3 is the same thing as 3 to the power of 2 over 3. So we can go ahead and say that x does indeed equal negative 2/3. And in general, it's just that logs aren't really all that difficult. Well, not logs, exponents. And the more we practice, it's going to get more simple, since they're kind of just basic rules I need to know. For example, like 2 to the power of x times 1 over 32 is equal to 32. Here we can go ahead and just factor this out, which will give us 2 to the power of x times 1 over 2 to the power of 5. And that is equal to 2 to the power of 5. And here we're also going to have 2 to the power of x times 2 to the power of negative 5. That is equal to 2 to the power of 5. So here we can go ahead and group the left side. So we have 2 to the power of x minus 5 is equal to 2 to the power of 5. And here we just solve for x minus 5 is equal to 5. And then we get that x is equal to 10, because 5 plus 5 is equal to 10. So we can go ahead and verify our solution by just plugging in x. So we have 2 to the power of 10, which is going to be around 1024. And if we multiply that, or divide that by 32, we're just going to get 32. Or instead of doing this huge step and taking away time, we can just go ahead and use this equation, which is this one, and just get our answer quicker. So we have 2 to the power of 10 times 2 to the power of negative 5. And here we just get 2 to the power of 5, which indeed is our solution from here. So that's the fastest way you could do it. Instead of having to use the first equation, just use the equation that is much more simpler and easier to use. We could have also used this one here to verify our solution, but I just chose the third step because it's the same thing either way. So now we're going to go ahead and look at a pretty complicated one. So here we have 1 over 6 to the power of 3x plus 2 times 216 to the power of 3x, and that is equal to 1 over 216. So let's go ahead and see if we have any perfect squares. So we have 6 squared, which is equal to 36, and 6 cubed is equal to 216. And here we have 216 twice, so we can rewrite it as 6 cubed. So we have 1 over 6 3x plus 2 times 6 cubed times 3x. And that is equal to 6 to the power of negative 3. And we can also rewrite 1 over 6 as 6 to the power of negative 1 times 3x plus 2 times 6 to the power of 9x is equal to 6 to the power of negative 3. And we could just go ahead and keep simplifying so that we get all of this. And now we can go ahead and group the left side, where we will go ahead and get 6 to the power of 9 minus 3x, which is positive 6x minus 2, and that is equal to negative, or 6 to the power of negative 3. So we can go ahead and solve for 6x minus 2, which is equal to negative 3, because we have the same base, so we have 6 at the bottom, and we always have 6 raised to something on both sides, so we can just go ahead and solve for 6x minus 2 is equal to negative 3. And we just go ahead and subtract or add 2 to both sides. And we're going to get negative 1. And we get that x is equal to negative 1 over 6. So we can go ahead and just clear up some space and verify one of our solutions, or verify our solution on one of the equations that we have. And we're going to verify it on the one that I have right here that I left on top. So with that, we can go ahead and verify it. So we have 6 to the power of negative, or 6 times negative 1/6 minus 2, which is the same thing as 6 to the power of negative 1 minus 2, which does give us 6 to the power of negative 3, which is our solution. So let's look at one more example, and that'll be the end of the video. So let's go ahead and look at (16 to the power of r times 64, 3 minus 3r, and that is equal to 64. So here we can go ahead and divide everything by 4, or convert it into a perfect square or cube, since we have 4 squared is equal to 16 and 4 cubed is equal to 64. So let's use this conversion onto our equation. So here we have 4 squared r times 4 cubed times 3 minus 3r, and that is equal to 4 cubed. And we can go ahead and just simplify, where we have 4 to the power of 2r times 4 to the power of 9 minus 9r, which is equal to 4 to the power of 3. And we just go ahead and combine the left side, giving us 4 to the power of 9 minus 7r. That is equal to 4 to the power of 3. Now solving for 7, or r, we could go ahead and get negative 7r is equal to negative 6, and that r is equal to 6 over 7. So let's go ahead and make sure that that is our solution. So let's just use this equation here in the brackets. So we have 4 to the power of 9 minus 7 times 6 over 7. And that is going to give us 4 to the power of 9 minus 6, which doesn't need to give us 4 cubed, which satisfies our equation. So that is the answer. We're going to look at another example where we have the 2x plus 3 root of 64, which is equal to the 6th root minus 2x of 128 squared. Here we get that 2 to the power of 6 is equal to 64, and 2 to the power of 7 is equal to 128. So we can directly simplify this now, which will make our solving much more easier. So let's go ahead and just simplify. And the reason we have 2 to the power of 14 is because 2 to the power of 7 times 2 is the same thing as 2 to the power of 14. So we just did that step rather quickly instead of having to do it step by step. So now we just have to solve for x, where here we have 2 to the power of 6 over 2x plus 3, which is equal to 2 to the power of 14 divided by 6 minus 2x. Since we have the same base, we can go ahead and solve for x now. So we have 6 over 2x plus 3 is equal to 14 over 6 minus 2x. Cross multiplying, we get that we have 36 minus 12x is equal to 2x times 14, which is 28x, plus 42. And subtracting 42, we get negative 6. And adding 12x, we get 40x. And if we solve for x, we get that x is equal to negative 6 over 40, or negative 3 over 20. So we can go ahead and just clear up some space here now. Well, actually, we'll keep that. And just clear this out. So now we have that x is equal to negative 3 over 20, which is approximately negative 0.15. So we can go ahead and get rid of this now since we already have it on the left. Let's go ahead and plug in x. So we have 2 times negative 3 over 20, which gives us negative 3 over 10 plus 3, which is 27 over 10, and 6 divided by 27 over 10 is the same thing as 60 over 27. So we have 2 to the power of 60 over 27, which is approximately, if we check its value or numerical value, we get 4.66611. And now for the right hand side, it is 14 divided by 6 minus negative 3 over 10. Since we have two negatives, they cancel out, giving us a positive. And we get at the bottom part is 63 over 10, which is going to give us 140 over 63. So we get 2 to the power of 140 over 63, which its numerical value is also 4.66611, which are the same values, but their radical form is different. So that is that for this example. And thank you for watching, and I hope you have a good day.